So the tool we will use, I will use Python, and there is a Python distribution called Anaconda that I recommend you to use. In Anaconda, we can go to this individual edition, which is this contains all the machine learning libraries we are going to need. And then you go to this page, and then you select for your operating system. So it supports Windows, macOS, and Linux. And you can just download it. And it contains all the libraries that we need, at least for the first part. That it contains libraries like scikit-learn that we will use for training a model, Jupyter, and so on. Every time I use a library, I will explain what this library is doing. So right now I'm going to open Jupyter, which is a web-based interactive environment for executing Python code. So I am on Windows, and on Windows I use Git bash. So this is bash that comes with Windows. This will probably work with the usual command prompt. I do not like command prompt, so I'm more like a Linux person, even though I'm on Windows. So if you're on Linux or on macOS, you can just do the same thing as I do. If you're on Windows, I think most of the stuff you will see will work in the same way. I am in this folder right now. It's empty. This is the folder that we will use for our project, and I want to start Jupyter. I already installed Anaconda. So now I will do Jupyter Notebook to start a Jupyter Notebook. So this is the interactive environment that we will use. This is how it looks. Now I click, I click New, and then I select this notebook. Oh, I click too many times. So for you, it will look like that. Oops. So for you, it will look like that. I hide these toolbars, so because they take a lot of space. And then I will rename it right now. I will call it, I don't know, train model train, for example. I didn't need the .py thing at the end. I remove that. And this is the environment, Python environment that we'll use. So you can see we can type some code and then it executes this code. So now I'm going to import a few libraries that we need. So the first library that we will need is called Pandas. So Pandas is a library for reading tabular data. And we will, for our use case, so our use case is churn prediction, we will need to get some data. So there is already a data set about a telecom company that we can just use. And I'm going to get this data set right now, and I will use Pandas for reading this data set. And for that, I will use a source code from the book. So this is my profile, and one of the pinned links, pinned repos here is this ML Bookcamp code, which is the code for the book. And then in chapter 3, and this is the chapter we are talking about right now, there is a link to a dataset. So I'm going to click on this link, and then I want to, I think I need to do something like question mark row to get it the raw version. Oh, no. Yeah, okay, I need to click on this thing. So if I was too fast, so here in this row, right? And then I just right click, copy link address. And then I do pandas, let me create a variable URL. So this is the URL of our data set. And with pandas, I can just do read CSV and then pass a URL. And then I will save it to a def variable. Def is short for data frame. Data frame is the level of abstraction we use, like the main data structure that pandas use, which is a fancy word for a table. So you see, this is all the information we have in our CSV file. So this is the data set we have. So the kind of data we have here is, so this is the information about the clients that we have, gender of the client, like if they are seniors or not, whether they live with partners or not, whether they live with the, I don't know, I think it's kids, how long they stayed in months with this company. Then what kind of services they have, like if they have a phone service, if they have multiple lines, if they have internet, and a bunch of other things. And the interesting thing for us, churn is at the end if they decided to leave the company and join a different internet provider or not. And these two monthly charges and total charges are also quite interesting. So this is how much monthly charges, how much they pay per month, and total charges is how much they paid in total. So we have this data frame, and for now we want to let me take a look at the columns that we have. Yeah, so these are all the columns we have in our data set, and we want to use these columns now to train a machine learning model. Let me quickly open the code. So I will be following this code that we already have in this repo. And I want to copy some things, so I don't need to type them because they're quite lengthy. But I will explain what is happening here. So the first thing I want to execute is this bit of code. So you see, when I do df, the names of these columns is like sometimes it's lowercase, sometimes it's capital case. Yeah, it's quite a mess, right? And the same happens inside this for values. And what this line of code, well, this bunch of lines of code is doing, it lowercases everything, and then yeah, it just does some normalization. And this line selects all the columns that are strings. So with this like female, yes, no, no phone service, and so on. So it will skip columns like tenure, like monthly charges and total charges. So let me execute this, and now you will see that now data frame looks differently. So you see that all the names are lowercased and the values here, so they are normalized. So this just makes it easier to work with. So we have this data set, and right now we want to first extract this churn variable. So this is the variable, this is the outcome we want to predict. So I want to extract this first. Yeah, maybe even before that. So usually in machine learning, when you have a data set, so imagine that this is our data set. So this is our data set. Yeah, imagine that this is like I'll use something like this. So we need to split this data set into 3 parts. So it will be one part. So this part is, we call it training part. Then there will be another part of the data set that we will use for validation. And then there will be a third part of the data set that we use for evaluating our model. So there's validation part and testing part. And usually we take our full data set and we split it into 3 parts. And the reason we're doing this is when we train a machine learning model, we want to understand that our models actually perform well. And that's why we train our model on this part, on the training part. And then we apply the model to the validation data set to make sure that the model still works. We do this multiple times, and then at the end we do one last check on the testing data set to make sure that our model is actually good. So we need to split this our data set into 3, and usually the distribution is 60% goes to training, 20% goes to validation, and then 20% goes to testing. So we want to do that. So we want to take our data frame and split this into 3 parts. And for that, we will use scikit-learn. So scikit-learn is the library for doing machine learning, but it has a bunch of useful utilities for doing things like this. So scikit-learn, from scikit-learn, in scikit-learn there is a package called model selection, and inside this package there is a train test split function. So this function is doing exactly that. It's doing the split. So we can take our data frame and split it. But the thing is that this function only splits it into 2 parts. So we will need to split it into, so first we will take this data set and split it into 2 parts. So it will be, we will split it into 80%, 20%. So this 20% will be testing. And this one will be training and validation combined. And then we will split one more time. So let me do that. So test size, this is the size of this part, of the second part. This is 0.2, so 20%. And then here we need to say that we want to set random state. Random state is needed to make sure that our results are reproducible. So every time we do the split, we get the same data sets. And I will call it data frame full train. and data frame test. So this is how it looks like right now. So it has 5,600 rows, and this one, data frame test, this is another part which has only 1,400. And these are completely, well, these are different records. And now we need to do it one more time. So we need to apply this function one more time. So now we will split this full train dataset into data frame train and data frame validation. And oops. And now instead of doing 0.2, we will use 0.25 because we want now this 20% to split into 60 and 20. Like if this 80% is actually 100%, then 20 is 25%. Well, I will not spend time explaining this now, just trust me, we need to do it this way. And then what we get is we get 3 data sets. So we get, we can check the length. So we have data frame train dataset, then data frame validation, and data frame test. So and this validation and test dataset, they are smaller, and this is the train dataset. This is the dataset we will use for training our model. We have these data frames, right? And we need to take this churn column from there. This is what we are going to predict. Because when we have a machine learning model, we need to have 2 things. So we need to have a matrix X, this is our training data, and we need to have vector Y, so this is the target variable. And the training data is what we use for training the model, and Y, this is what we want to predict. So in our case, this is churn, and X is everything else. What we have, like from gender, senior citizens, citizen, and so on, till total charges. So this is like all the columns except churn. Well, we also don't need customer ID. That is not a useful column. So except churn and customer ID. We will use this information to predict if people now want to leave a company or not. And yeah, so right now we need to get this X. Well, first of all, we need to get this Y. And to get this Y, so we have this churn column, right? So churn. So when I do just data frame.churn, I get a column from this data frame. And yeah, we want to build a model that will predict if people are going to churn or not. But for Y, so this Y, it should be either 0 or 1. So we need to write something like this. So if churn equals yes, then we have true. And true is, well, it's like 1. And false is 0. And we can turn this into an actual number if we write as type int. And then you see we actually convert this to an integer. So this will be our target variable, this Y, what we want to predict. And yeah, I will do the same thing for validation and train. So for validation and then for train, test, sorry. So we get this Y train, Y validation and Y test. And now we need to get this X matrix, right? For that, so what we have right now is just a bunch of columns. So how do we turn these columns into a matrix? For that, there are things called encoders in scikit-learn. So they take these text values, these zeros and ones, these numbers, and they give us this matrix X that we can put to a machine learning model. So I will now import it. So again, from scikit-learn, I want to import, I think it's feature extraction, import dictionary vectorizer. Yeah, so this is what I want to, yeah, so this is called a vectorizer. So vectorizer is a thing that turns this data, this text into a vector. And vectors and matrices is something that we can put into a machine learning model. So that's why it's called a vectorizer. But the other part of this name is called Dict, which means it expects a dictionary. So first we need to turn our data frame in a dictionary and then put it to a dictionary vectorizer. And then this is what we will put in our machine learning model. So for that, yeah, and as I mentioned, we don't need customer ID, we don't need churn. So what I will do now is I will delete them from the data frame. So I will do delete data frame train customer ID, delete data frame train churn. So now if we take a look at this, we don't have it. So we have gender and we have total charges, so we don't have churn and customer ID. And now we need to turn this into a bunch of dictionaries. So I do now data frame train to dict. So this turns the data frame into a bunch of dictionaries. And then I say orient records. So then each row becomes a dictionary. And then I will call it dictionary train. So if we take a look at this right now, so let's take a look at the first 5 elements in this list. And you see this is how it looks like. So our data frame, each row of the data frame turned into this dictionary. Right, and now we can turn this dictionary into a matrix, and we will use dictionary vectorizer for that. So I will call it dv dictionary vectorizer. I will create it, and then I will call fit method of this dictionary vectorizer. So it's sort of fit goes through all the records of our list and then sees what are the columns there, and then it kind of learns how exactly it should convert this dictionaries, this list of dictionaries, to this capital X matrix. So I will do fit. So now it learned how to do this, and now I need to do transform to actually turn these dictionaries into a matrix. So, and the matrix will be xtrain. And now we have this matrix. So this is a sparse matrix. I do not want to go into details what sparse actually is, but I probably want to tell you I want to show you like how first few records look like, or maybe before that I want to show you how names look like in this. So these are okay, so we have actually an error here. Let me explain what the error is. So here you see we have for each variable that we have in our data set, we have like contract month to month and so on. And then for total charges, it's supposed to be a number, but then like for each total charges, we get like a value here. And the reason for that is there is a mistake in well, there is an issue in the data. So let me take a look at this again. So if we look at this total charges, we see that the type of this is object, but should be a number. So we need to parse this, to tell Pandas to parse this, to turn this into a number. And for that, I will do Pandas pd2 numeric. And now it will try turning this. And yeah, it says that there are some things that it cannot parse. And now we need to tell it that, okay, if there are things you cannot parse, you just ignore them. And for that, we use errors coerce. Hope I spelled it correctly. And yeah, so what happens here is when it cannot parse a value, it will just put a not a number there. So now we also need to replace these not numbers with zeros, like that. And this way we ask Pandas to actually parse this. So I will put this thing here. And now I need to do this whole thing over again. Re-execute this. And now you see we have this is gone. So we have only things like contract, dependence, and so on. So these are all, this is the information we have about clients. And we have our matrix. Now we can take a look at the first row, 5 rows of this matrix. I will call it too dense, that now it will turn into like an actual matrix that we can see. Oops. Yeah, but so this is how the rows of this matrix look like. So it's mostly zeros and ones, and then this is like total charges and so on. I will not go into details, but this is what our model sees when training. And now let's use this for training our model. So the model we will use for this is logistic regression. So this is a classification model because our target is churn or not churn. So we are classifying people into 2 categories, people who are going to churn and people who are not going to churn. So for that we use classification models. And one of the models that is useful for that is logistic regression. So it lives, the implementation of this model in scikit-learn lives in the package linear model. So from linear model import logistic regression. So we import this. And now we can train our model. So first we initialize the model. And then we do model fit. And we pass this capital X matrix that we just got. And we also need to give it our Y train. Yeah, so it complains about something. So we can say, so it says that there are not enough iterations. Well, ideally we can just ignore this warning, but let me quickly fix it. Okay, now it works. So now we have this model, we trained this model, and now we want to understand if this model is good or not, how well this model actually predicts customers that are going to churn. So for that, remember I showed you that we need to split data into 3 parts, right? So this is what we use for training, and then there is another part that we use for validation. So we will use now validation to understand how good the model is. Let me apply the model to our validation dataset. And for that, I will need to do the same thing here. So I will need to remove customer ID and churn from our training dataset. And then I will need to turn our data frame validation into a bunch of dictionaries. Oops. A bunch of dictionaries. So data frame validation to Dict, and then orient record. So now we have this bunch of dictionaries. I shouldn't have done this. Yeah, but like it prints for every record we have, it shows how it looks like. And now I need to do this transform thing to turn this list of dictionaries into a matrix. So I do this. And now we have this matrix that we put in the model. And we do model predict. So instead of train, we do predict. And we put, our validation matrix. And this is what it outputs. So it outputs a bunch of zeros and ones. So these are our predictions. I will call it Y prediction. And now we need to understand how good our model is. And for that, we can use a thing called accuracy. So it tells us what is the fraction of correct predictions. So we'll import from scikit-learn metrics, we'll import accuracy. And now we can use this accuracy to understand how well our model is doing. So we have our validation Y. We know actually if these people churned or not. And we know our predictions. And we can just put these things here, and we see that our model is 80% accurate, which is not too bad. Yeah, I think this is good enough for now to go ahead and deploy this. Of course, we can go and improve this model and ask ourselves if 80% is actually good. Can we make it better? How can we make it better? And things like this. But I wanted to show you the end-to-end process. So now we trained a model. Well, ideally, there is this third step of testing the model. We can do this as well, but yeah, I will not do it right now. But what I want to do now instead is I want to show you how we can take this model and turn this into a web service that we can use for serving this model that we just trained. So before we can do this, we need to save this model. So we need to save the model, and we need to save this dictionary vectorizer. So there are actually two things that we need to save. So I will use a model in Python that's called pickle. And this is, I think, for saving things and for loading things. And the way I do this, I open a file. So I'll call it model bin. And then I need to open it in the write mode. So because I am going to write to the file. And then I need to open it in a binary mode, because this pickle writes things in a binary format. So I'll open a file as foutput. So this is the name of the file. And then I use pickle to save. It's called dump. I want to save on the dictionary vectorizer and the model. So we'll actually save two things. So we'll save both of them. And now I need to specify that I want to save them to this file foutput. And now we can see that in our folder, we have this model.bin file, which the size of this file is 2.4 kilobytes. And this file now contains these things.